the data like vector data, raster data. I
Okay.
have some work done on thematics, just like making thematics maps and how to download the shape files.
Okay.
Uh, yes, sir,
And
that is.
and where are you doing your master's from?
Uh, Amravati University, Sant Galge Baba, Amravati University, Maharashtra.
Okay, okay. Good to know. Okay. And you're in currently in third semester, right?
Yes, yes.
Okay, okay, okay. As I understand, like I've done my master's in geology from India, and previously I've seen many curriculums. There is this problem in India that they just teach about they never go to the programming part, or they do not,
Yeah, yeah,
most of them
yeah,
do not
exactly.
have the even the access to ArcGIS or something, right? So it has
Yes,
been,
yeah,
I don't understand the point of these masters. So they lack the basic digital infrastructure. They don't tell about the very important part that is in today's technology, that you need to understand programming,
yes,
right?
yes, sir.
Okay, okay, good.
They
Will
they are saying that you are done yourself. We can't do anything. Huh.
yes, yes,
Just they teach basic things, and that's all.
that is a major challenge. Yes.
Yeah.
Okay. Anyone
Okay.
else would like to give an intro? Or maybe you can just write in the chat your name and where you're doing your master's from, or what are you doing. So there are some new users also. I told already. Myself Akshay, and I have a double master's in geology and as well as GIS. So I currently hail from Chandigarh and I live in Chandigarh, and um I have 4 to 5 years of working experience in GIS. So this first part, that is the foundations part, I will be teaching that to you. Okay. So anyone else would like to give an intro? So we had the two intros. Anyone else? Okay. No worries. Now we will wait just like 4 to 5 minutes. Maybe some other people will join the class, and then we will start the session. Okay. So whenever in class you have a doubt, you can directly write in the chat box, or you can directly turn off on your mic and you can tell me the doubt. So this is not a traditional classroom, right? So that I have to complete my topic and you can't tell anything in between, right? At the point you have any doubt, you can just directly shoot off that uh, query to me. Okay. So you don't have to wait, and maybe you're not able to understand anything, right? What I mean by anything is, maybe you are not able to understand a topic. What you can do is, you can tell me to repeat it. You can have a one-to-one session with me again. I can explain that topic to you, or maybe in the class I can repeat it. It is no problem, because you don't have to grow with confusion. You have to clear all your understanding of your topics, right? So if you don't have the clarity, that will always become a blockage in your understanding of the application. Okay. So let us just wait 3 or 4 minutes, and once everyone is here, we will start the class. Okay. So we have 13 participants as of now. Um, let me say again, my name is Akshay. Okay, and I'll be your tutor for this uh, current track. So as per your course, so you have this track one, that is Foundations of Geospatial Science. So that will be covered by me until the very end. So at the end of this project, at the end of this track, there is a project that you have to do with me. You will do one single project about whatever you learned in this. So we have defined 40 projects. You have to select one of the project after that, and you have to complete that project. So once you are done with this project, you proceed to the next part. So track 2 and track 3. So the tracks that are further ahead will be covered by someone else. So I'll be teaching you the foundations of geospatial data science. So if you talk about on the very basic side, sometimes we lack some knowledge about our understanding of GIS. So because of that, what happens is there are some things when you are actually doing the application, you get confused that why we are doing this. You know the method, but you don't understand why you are doing that, or maybe what that thing is based on. So we will go from the very basic. We will try to understand each and every concept about GIS, what GIS is, what remote sensing is, what is vector data, what is raster data, what are the things associated with it. Okay. So just before we go ahead, out of all the participants, can you let me know in the chat or maybe by voice if someone is very new to GIS, that they have not studied about GIS any time before, and this is like they are very new to it. So I can understand the variation in the class. Okay, just let me know in the chat, or maybe you can use the voice. So we'll start the lecture. I know basics. I'm very new to GIS. Nikhil. Okay, okay. Nikhil, what is your background? Is it, can you tell me your background? Okay, Guru, can you also tell me your backgrounds? People who are new to GIS, can you tell me your background? Like you have done your bachelor's in, or you're doing, or your, what are you doing your master's in, or something like that?
Sir,
Yes, sir.
myself Gurunath.
This is Nikhil. Okay.
Uh, okay, Nikhil, can you tell first?
Okay. Sir, my background, graduation background is computer or MCA, you can say. I have done
Okay.
my post graduation in Master in Computer Applications.
Okay, okay, okay. So, what is your motive to learn GIS?
Actually, I'm working in drone tech company,
Okay.
and GIS or Geo AI is related with today's drone technology. So
Good
that's
to know.
why
Good
to upskill myself, I'm looking after this course,
to know.
and I'm interested in all these technologies.
Okay, okay, okay. And Guru, yes, what is your background?
Sir, I have done my bachelor's in statistics and also master's in statistics.
Okay,
Currently, I'm working as a data analyst in insurance company,
okay.
and I'm also interested in I was always curious about the satellite data as well as
Uh-huh.
GIS data sets. So I
Okay.
wanted to just, for sake of curiosity, I have just joined the class.
But it is a very rare combination for someone in statistics, and if you are working in an insurance company, it can take you very far in this field, right? It can open new ways.
Yes, sir. Yes, sir.
Okay. So, uh, now I will go slow because this is the first lecture and you need to understand the basics very well. Okay. So if at any point you are stuck or you skipped anything or you're not able to understand or you think I'm going fast, you can just let me know. Okay. No worries. I'm not your classroom teacher that I will be rude with you or something, right? You are paying us and you have all the time to understand it. Okay. This is your power over me that you can ask me again and again and again. Okay. So you need to clear your all doubts. Okay. So when we talk about geospatial science, what is geospatial science? Let me first give you an example. let me say the word where. Okay. So we have developed something called as a spatial reference. What it means is, if I am telling someone, come to this place, I will give him a landmark, right? I will tell him maybe come to this ABC school, near this ABC school, or maybe come to this near this ABC hotel, right? You gave him a reference. So the other person knows where that reference is, and based on that reference, he was able to come to that place. Now, in today's world, we had to develop some model of this spatial reference. We defined something digital. One of the possibility that we have defined, it is called as latitude longitude. So everyone is familiar with what latitude and longitude is. Don't worry if you don't know the mathematical meaning of it, but you know that latitude longitude means the location of something. So if I send someone a location, if you're sending someone a location, basically it sends it a latitude longitude, and it helps it to understand where the person is located, right? So you can broadly say that it is where is what we tried to model. So anything with a spatial reference is a part of geospatial science. Anything that forms a spatial reference, how we created it, how things work with it, how we understand it, how we manipulate it, or how we use it as an application, everything is a part of geospatial science. Now, in earlier in historical times, what happened was there was no digital systems, right? There was no computers, there was no satellites. Then, how did GIS evolute? How did this map making thing come into being? So, before GIS, we were more dependent on cartography, that is, creating maps, that is, creating uh, maps of the using hands or using scales or something, right? So, if you are living in India, or maybe if you are from another country, uh, you may probably know that there are some kind of historical maps with the revenue department. So in the previous time, they have this cadastral records. That is, it it is the record based on what they have created with the field surveys and their own hands. There was no use of any digital technology. So one of the earliest examples how this cartography, how this understanding of where can be helpful to us. Okay. Now, one example is from the 1854 London cholera epidemic. Now, what happened was in London, there was a disease called as cholera. It was widespread. Now, the authorities were unable to understand why is it spreading so much, where did it come from. So there were many deaths that were happening due to cholera. So then came this one man called as Dr. John Snow. What he did was he took the map of London, right? This is the map of London. He took the map of London and he placed all the people's location who died. So, if someone was living at this house and he died of cholera, so he mapped all the people who died because of cholera. Basically, he did a field mapping. So, what he did next was he tried to understand using this map the density of the points where it was more. So he was able to locate that the density of this is more here, right? So based on the density, they were being able to understand, because it is a communicable disease. It spreads from one person to another. It is via contaminated water or something, right? So they were able to understand that the source is somewhere near here. Okay. Now using this map and this spatial reference, that is the mapped houses, they were able to identify the epidemic source, that was a contaminated public water source, like a hand pump. It was contaminated. So from that, they all people were drinking water, and they got cholera. So then this pump was eradicated, it was removed, and this cholera thing was stopped. So just try to see, there was this problem, and the person resolved it using the power of where. So this is one problem. So in today's day, we have thousands of problems, thousands of things, and we try to have a solution of it using the power of where. That is, we try to solve it using spatial references. One example is, if you see food delivery apps, taxi apps, okay, so they all are highly dependent on the maps. So if there is traffic in one route, it tells them, okay, this route is trafficked. You need to go through another route. Okay. So this all is now being done using the power of maps. Now, there are two parts of geospatial science. One is called as remote sensing, and the other one is called as geographic information system. Now, these two things, I will explain the definition, but you need to understand that they go hand in hand. So, one is incomplete without the other, right? What I mean to say is, okay, before I go ahead, there is this one thing that I wanted to say, because this first one or two lectures are more about theory, because first we need to understand the theory, then we will move to practicals. Okay. So these are two things. One is remote sensing, one is GIS, and they go hand in hand. One is incomplete, almost, you can say, if one of them does not exist, the other one is not possible. They are also dependent on each other. I will explain how. Now, first of all, the definition of what is remote sensing. So just imagine you are sitting at your home and you have a television in front of you, right? So, and you have a remote control in your hand. So you can change the channels of that TV from that remote control, right? So just try to understand why it is called a remote control. It is called a remote control because you are remotely, that is, you are not touching the TV, you are at a distance from the TV, and you are able to remotely control the television. Okay. So similarly, what remote sensing means is, when you have any object, that can be a satellite, it can be a drone, anything which is not in physical touch with the earth, that says the definition, right? Remote sensing, that it is not in the physical touch with the earth, it is remote, it is away from the earth, and it is able to sense the object's properties on earth. So when we are trying to use a satellite or a drone or anything to understand the features of earth, or maybe taking the image of earth, so we are remotely trying to sense the objects of earth. So this art or science of obtaining information about an object or phenomenon from a distance, it is called as remote sensing. Okay. I hope the definition of remote sensing is clear. Now, if you look at this image, so one of the question is, what do satellites actually measure? What is happening at the sensor of the satellite? So the sun is giving out some kind of energy. So if you are from physics background, or maybe if not, you need to understand that the energy that is coming from the sun, it has a wavelength, it has different wavelengths. What I mean to say is, if you uh, if you see here, this energy that is coming, it gets reflected from every object on earth. So maybe it comes and interacts with the bare soil. It comes and falls over the grass. So whenever it comes and interacts over the earth, it gets reflected. So once it gets reflected, it is collected by the sensor of the satellite. Now what happens is, every object on earth has a very different property. What I mean is, for example, if 100 units of energy is being sent from the sun, so this object has a such property that it reflects, sorry, so this has such a property that it reflects 70% of the energy. So 100 units came and 70 got reflected. Or maybe if you have water, 100%, 100 units of energy came and only 40 got reflected. So every object on earth, just carefully understand this, every object on earth has its own property of reflection of the sun's energy, that what percentage it reflects back. Okay. So similarly, there are also gases in the atmosphere, right? So our atmosphere is made of gases. So even our atmosphere reflects some energy. Do not worry what percentage, but just you need to understand is, everything on earth's surface as well as the atmosphere, it reflects the energy, and once this energy reaches the satellite sensor, we are able to create a image based on the energy. Okay. Now there is two types of remote sensing. One is called as passive remote sensing, other one is called as active remote sensing, and it is defined because of the passive instrument and the active instrument. Now, what passive remote sensing actually means and what active remote sensing means. Now, in this case, if you see, there was a source of energy, that was the sun. If you have a source of energy and the energy gets reflected and then is being recorded or sensed by the satellite, in that case it is called as passive remote sensing. For example, if you are working at night time, you want to make an observation on earth at the night time, do you have the sun's energy available? No. Then in that case, the satellite, there are some satellites which can produce their own energy. So for example, it is night time, or maybe it is heavily clouded. So we have some instruments that can produce their own energy. Once this own energy goes to the earth and it gets reflected back, in that case it is called a active instrument. So during my college I had a hard time remembering the word. I used to forget which one is passive, which one is active. So I remembered it like, so the word P is very near to the word S as compared to A, right? So sun, like PQRS. Okay. So now you can remember that passive always means the one that includes the sun's energy. Okay. So here is an image. If you can see any object, for example, you have the International Space Station, you have major satellites, so you have CubeSat, these are small size satellites. Anything that is not in physical touch with Earth, it can be a drone, it can be a hot air balloon, right? So anything, it can be an aeroplane. Anything that is not in physical touch with the earth, it is able to do remote sensing of our planet. Now, for example, there is an instrument called as GPR, that is ground penetrating radar. So that is a thing that can be connected out to the surface of the earth, and you can move it on the surface of earth, and it tells you about the subsurface, what are the layers beneath the earth. So it is in contact with the earth and it is telling you something beneath. Now, because it is in contact with the earth, it is not a part of remote sensing. Got it? The basic criteria of remote sensing is it should not be in physical touch with earth. Okay. Now, there are some principles of remote sensing. What do you understand by principles of remote sensing? So, principle means how the system actually works. So if you remember, we talked about remote sensing and GIS. We are just currently talking about remote sensing, how remote sensing actually works. So the basic part that you need to remember is there is a sun or any source of energy. It can be the satellite itself. That source of energy, first of all, interacts with the atmosphere when it enters the earth. It interacts with the atmosphere, then gets reflected from the target, right? After getting reflected from the target, it again passes through the atmosphere and then is collected at the source of the satellite sensor. Okay. Once it is collected at the sensor transmits it to the ground station. So do not worry about what this is. This satellite is transmitting it to the ground station. What this is, that sometimes the satellite is very far away. You need another satellite that is low Earth orbit. You send the data to this and then it sends to the ground. Okay. So the data from the satellite. So the data is captured here. There is no processing being done on the satellite itself. The raw data is sent to the reception on the reception end of the earth. Then this data is sent to the processing station. Okay. Now in processing station, there can be many things. There are some errors because of the movement of sensor, or maybe there is some atmospheric error. There are errors. There are things that can cause error. We will understand it later, what can cause error. But there are some errors in the data that needs to be removed. Maybe your sensor has some kind of problem, some defects, right? So all that data needs to be uh, processed, and after processing it is sent for final application. So for example, you using Google Maps, so that is the final application. Got it? So this is the principles of remote sensing. If anyone has doubt until now, you can just directly ask or you can write in the chat box. Okay. Now, there is something called as the electromagnetic spectrum. What is a electromagnetic spectrum? So if you remember here, the sun is sending off some energy. Okay. The energy actually is moving like this. We cannot view it with our naked eyes, but the energy moves like this. Okay. So, in terms of physics, we can define, just a moment. So if you look here, the energy travels something like this. Now, there is not a single energy. There are multiple levels of energy that is coming from the sun. What it means is that sun is a source which is sending off energy of different wavelengths. What it means is, for example, this is one wavelength. This is one wavelength. In physics, there is this term because the waves are traveling like this, right? So in physics, a wavelength is equal to the length between two consecutive crests. So the crest is something like this hilltops. So this is the value of wavelength and we represent it by lambda. So our sun is emitting energy that is of different wavelengths, not a single. So we have energy that can be produced in all these wavelengths. So if you see here, if if it is a size of the building, if the wavelength is the size of the building, we classify it as radio waves. If it is very small, if it is as small as the atom, the wavelength size is so small. So the lambda that I said, that is, this is the lambda, right? Now the value of lambda is this. So if the value of lambda, that is the distance between two consecutive crests, is 10 raised to power 8. I think it's meters, right? Yeah. So if it is 10 raised to power 8, it is as big as the buildings. It is radio waves. And it can go until very small. So the size of humans, then the butterflies, it can go up to the size of atoms. So in that case, it is called as gamma rays. So our eyes, our human eyes have this characteristic that we are just able to visualize the visible light. What it means is there is a certain extent of wavelength that is between there is a certain extent of wavelength that is between here to here. The energy that is inside of this zone can be viewed by human eyes. And this energy, so in your day to day life, if you see all around, you can see colors, right? So that is because of the energy, that is the wavelength. But because we are as humans, our eyes are just bound to see just between this wavelengths. Okay. So every wavelength gives a characteristic color, and based on that colors we have named the wavelength. So if there is a wavelength because of which we see the red color, and we have called it as red because of the characteristic color of it. Now if you see, if you go to a medical hospital or somewhere, there is this concept that you need to understand that every wavelength has a certain property, how it can view the object or how it can penetrate the object. Okay, that is how it interacts with the object. Now we with our bare eyes cannot see x-ray, right? But in hospitals we have been so capable that we have been able to create the all the sensors we have. In today's term, human has been capable and able to create the sensors in all this wavelengths. Now when you go to a hospital and you get a x-ray, maybe you have a broken arm, so the particular wavelength in this zone has such a characteristic that it can penetrate your skin and tell you how your bones are inside, right? So that is the character of this wavelength. What if you were able to see X-rays with your eyes? If there was an option to see X-rays with your eyes, you could directly see inside your skin. From your bare eyes, you could directly see inside your skin. But as human, that is not possible. The God has not given us the possibility to see it with our own eyes. But we have been capable enough to create sensors that can sense the X-rays, emit the X-rays and sense the X-rays. So similarly, we can create satellites in all of these wavelengths. We can create satellites that can emit all of these and also uh, sense all of these wavelengths. So maybe all of them are produced by the sun. We have a sensor that can detect all of them. Okay. So is it clear to everyone, or this may be a little difficult to understand? If anyone has a doubt, you can just directly ask, or maybe if you want me to explain again. Okay. So it's clear. Okay. So then comes the next thing. Okay, before we go to the next thing. So there is this, if you look at this graph, now what happens is the energy from sun in all the wavelength is coming to the earth, right? It is entering the earth's atmosphere and interacting with the earth's atmosphere. But there, the atmosphere has such a characteristic. Our atmosphere has this characteristic that it absorbs most of the wavelength. Now, what it means is, if you see, if the wavelength is from 0.1 to 0.3, okay. Uh, so 0.1 to 0.3 is here. So the sun's radiation, sun's energy from this zone, when it enters the earth, it is completely absorbed by oxygen in the atmosphere. So if you see, it is completely absorbed. Only the visible range and some part here, if you see, the visible range is not absorbed by the oxygen, and because of which because there is no gas in the atmosphere that has a characteristic that it can absorb completely the visible range. So that is why you are able to see things around you. For example, there was some certain gas and it absorbs all the visible light. If it was in the atmosphere, our earth would appear to as dark to us, because we cannot, our eyes are not capable to watch in any other wavelength, and visible one also got absorbed by some gas, then we are done. Okay. But by God's grace, we are able to see in the visible zone, because only oxygen is absorbing a little part of it. Okay. So if you see the others, if you go to infrared, thermal infrared, you can see carbon dioxide is absorbing, water vapors is in absorbing infrared, carbon dioxide again is absorbing. Okay. So you need to, this is to understand how our gases in the atmosphere behave with the incoming radiation. So, for example, you create a satellite that works in this wavelength. Okay. You create a satellite and you create a emitter for this wavelength. Do you think it will be helpful? Because when, if this is the satellite and you are making this sensor and you are sending this wave to the earth, so all it will be absorbed by the oxygen in the atmosphere, and that satellite sensor will be useless. Okay. So you also need to study about how different wavelengths interact with the atmosphere. Then only you can do further analysis. Okay. So after remote sensing, we come to another topic. As I said, it goes hand in hand. That is called as geographic information system. Now, what is a geographic information system? So, once you capture a raw imagery from the remote sensing, you were able to capture the observation on Earth. So, you take the raw imagery, right? And based on that raw imagery, you create some maps. For example, you extract all the roads for navigation, or maybe you extract all the agriculture lands for understanding your agriculture lands. Okay. Or maybe you take up all the built up area to create a urban map. So when we take a raw imagery and do some kind of digital analysis of it, for example, I create a elevation map, that is the height of everything. Maybe this is a building, this is a tree. So I create a map which in a map where at every point I have the value of the elevation on ground. Okay. So I create this from the raw data, right? So when I create some digital products from this raw data and analyze it in an application, so it forms a geographic information system. So I would say an example of this is so if you see this map, is this what the actual Earth looks like? No, right? The actual Earth looks like this. And they took that raw imagery and they converted into this digital data. So these buildings have been created by the computer or the person, right? So this river has been digitally created. Okay. So if you see, the original length is this, but you have created a digital product out of this based on your understanding of it. So this digital interface of it and how we are using it in application, that forms GIS. Okay. So basically, remote sensing is all about capturing the data, and geographic information is about using that captured data to store it, analyze it, and visualize it. Okay. So a spatial data, data that has a geographic location attached to it. Now, a spatial data has two sub data types. What it means is, for example, if I say I make a building that this is someone's house. So, first of all, it is a spatial data. That is the geometry of this house, that it is a polygon. Now, if I add a metadata to it, that is, if I add a file to it which stores some data, that is what is the house number, what is the number of people living inside this house. So I have some text data that I have associated with this geometry. This geometry is spatial data, whereas the data that includes the information, the textual information, that can be called as the metadata of this spatial data. So that textual information is attribute data. It enriches your spatial data with meaningful information. So what if it was just a building? I don't have any information about it. It is very less meaningful, right? So what if I know the house number, the number of people living in it? That attribute data makes it more meaningful. Okay. So your data type has two types. One is spatial data and attribute data. Okay. Now there is something in GIS that is called as, does anyone have a doubt?
Sir, can you please example for that spatial and what is that?
Okay.
The table slide.
Okay. This one?
Spatial and attribute.
Yeah. Okay. So, do you see this river kind of thing, right? This
Yes.
canal inside of the city. So when I converted it into a digital format, I created this line, right? The Google created a line. So
Yes.
that is the geometry of it. But there was some text data added to it. So this is the text, the name of the river. Okay. So the line represents the spatial data and the textual information. The added information is called as the attribute data. For example, this is one point, right? So this point, this polygon, or maybe this point, it is the spatial data. But this photograph and this name added to that point, it is called as attribute data. So if we don't have this attribute data, it won't be much meaningful, right? So for example, this
Yes.
one, this block, if you look here, it is just the spatial data. There is no attribute to it. It is less meaningful to me than this one, right?
Yes.
Okay.
Thank you, sir.
Yeah. So then in GIS, there is something called as vector data and raster data. What it means is, so maybe you want to consider a area of interest. What I mean to say by area of interest is, for example, uh, okay, for example, I have this is a map of the city. This is the extent of a city. Maybe this is some, or maybe this is some locality. Okay. Now I want to point out the toilets in that area. So I put some points and I mark some points wherever the public toilet is. Okay. Okay. Now, if you see, other than the points, other than the points, I do not, I have not defined the other space. This is empty space. I'm not defining it. So there will be a value here that is a spatial data and an attribute data has been added to this location. But for the other locations, I have not defined anything. So it is null, that nothing has been defined in this area. So when your data is not continuous, it is discontinuous. It is called as vector. So what I mean by continuous is, what happens in raster type of data, this is basically a way of presenting data. Okay. So when you talk about vector, you simply were able to create points and tell, okay, these are toilets, public toilets. And when you select, you click here, it will select the toilets. But when you click here or outside anywhere, nothing will be selected because nothing has been defined for it, and it is a and the data is not defined in this region. So if you are selecting the toilets as whole, only these points will be selected. But whereas how continuous data, that is raster data, works is that in the area of interest, you need to have a value for every pixel, for every grid. If you see here, there are small grids. What these grids represent is a small part of image. So if you see, if you are watching YouTube, right? So there is this option of pixels in the image, video 720p, 180p. That is uh, pixel per inch, right? So basically, these are like this. This is an image. A raster format is very analogous to what a image is. So in an image, these are the pixels, and the pixels, we mathematically represent them as a small grid. Okay. These grids. Now, if I say there is in this image, I have to represent the public toilets. I will represent in these points, but I can't say that these rest pixels are not defined. So this data is such a type that I have to give them a value. Maybe I will give them 0, but I have to define a value for even the empty spaces because of how this data type exists. Okay. So when, if I click here now, I will get a value 0. It is defined. The value for this pixel is defined. It is 0. But whereas when I will click here, it will say not defined. If I click here, it will say yes, public toilet. If I click here, it will give me a value yes, public toilet. But the main difference between a vector data and a raster data is it is a continuous data. Raster is a continuous data and vector is a discontinuous data. So we talked about the example of point. Okay. Then let us talk about a line. Maybe I have to represent in some region the rivers flowing. Okay. So what I will do is I will just create the path of the river. So I have defined these lines only. This empty area is not defined. I have not defined this empty area. You can, when you select the river, only the rivers will be selected. Okay. Now, similarly, if I want to define this lines, not in vector, but in a raster format, I told you in raster, you have to define every other value also. So here I call the river pixel value as 1, but I have to define a value and I call it 0 for the pixel value that is not defined in here. So if I click here, whole of the raster will be selected. Whereas if I click here, only the river will be selected. So similarly with polygons. Okay. So maybe I want to represent the continents, and this green, yellow, and these are continents. So I defined 1 continent, 2 continent, 3, 4, and 5 continents. And I don't define this blue area. I leave it not defined. I've just defined these polygons. Again, this is a discontinuous data, right? So if I want to represent it into a raster format, I have to give the not defined area a value that is 0, but I have to define every inch of the extent. So every pixel in this extent has to have a value. It either it can be 0 or something, but I have to define it. Okay. So this is how raster format works. Okay. So this is very important to understand what a vector and raster is. If anyone has any doubt in the definition of vector and raster, you can ask me again. Okay. If you still have any doubt, just let me know in the chat or you can directly talk to me. But this is very important for you to clear what vector and what a raster is. Okay. Any doubts, please? Okay. Now, yeah, okay. So, after we understood what remote sensing is, what GIS is, now we need to understand how a raster is defined. So, in vectors, it is very simply defined as a point, a line, and a polygon. So, we have softwares, for example, like QGIS and in ArcGIS. We are easily able to create vectors, that is a point, line, and polygon. But how does a vector look? Okay. So one of the examples of a how does a raster look? Sorry. So one of the example of the raster is and the definition of pixel. Okay. So if you have any image, when you zoom into that image, you some boxes will start appearing. Some small boxes will start appearing. Those boxes are the pixels. Okay. Uh, maybe for example, so if you look at the satellite image here, after zooming it, something box tries to appear. So this box is called as the pixel. So pixel is the smallest unit. So this whole image, as I told, in a raster, the whole image can be represented as a group of grids. So once you represent the image as grids, there is a value because of which you are able to visualize the image. At each of the boxes there is a pixel value. So what this pixel value actually means is, so if you remember here, if the sun was sending some energy, maybe 100 units, okay, so it got reflected, right, and maybe 70 got reflected and the sensor captured it. So the sensor will give allocate a pixel when it will create an image. So the pixel that is here, that is the pavement. So the grid of it will give it a value 30 because 30 was reflected and recorded by the sensor. So if you see here, this is the recorded value by the sensor in the satellite, and that is what constitutes a image of the earth. So basically what is happening is there is this uh, digital analogous of energy, that is whatever is being reflected from the earth is being captured by the sensor, and it in the form of grids is given to us, and it looks like a image. Okay. Just a moment. So the very simple example of it is if you're watching a TV, right? So everything has a grid, and that grid has a color. So they are so minute that when they are together, it can kind of form a image. You are able to see TV, right? So you are able to see two people in the TV, and it is in the very minute level, it is formed by pixels. Then one of the very important concept in GIS is something called as coordinate system. Now, what coordinate system is and why do we need to understand it and what is the use of it? It is very important to understand what a coordinate system is because to many people, this coordinate system is not clear and it trails on for life. Like they don't understand what coordinate system is, and then it creates a problem for them when they are doing some GIS analysis. Okay. So if you remember, I told you latitude, longitude is something not real. It is digitally defined by us that every location on Earth has been given a lat long value, right? We have created a digital model of the Earth based on which we have given it a spatial reference. So this is very much related to coordinate system. We have a coordinate system based on which we were able to define the latitude and longitude. So it is more like uh, if you are reading a book that is in English, you first need to understand what English is. You first be able to understand, read and write English, then only you will be able to understand the book, right? So you need to have an understanding of coordinate systems to understand this concept of digital models. Okay. So there are two type of coordinate systems. One is called a geographic coordinate system and another one is called a projected coordinate system. Okay. Now, the basic difference between two is whenever someone talks about geographic coordinate system, he or she will be just, I will give you a overview. Whenever you see a data that is like in this format, that is, it is in degrees, then automatically just understand your in your mind that it is a geographic coordinate system. Why I will explain. But whenever it is in the form of plus and minus and in meters, okay, it is projected coordinate system. So in geographic coordinate system, we call it as the latitude and longitude. We are using it so commonly that we call it that we all know about the latitude and longitude. But in projected coordinate system, it is called as northing and easting. Okay. So whenever someone gives you a coordinate system, just directly when you look at the units, you should be able to understand which kind of coordinate system it is. Okay. Now, if you see this image, it will help you basically understand the difference of both. That what a geographic coordinate system is, what a projected coordinate system is. What happens is when you represent Earth as a spherical model, it is called a geographic coordinate system. As a, it could be an ellipse or anything, but it is more like a 3D geometrical curved surface. Okay. But when we represent Earth on a plain paper, so you can remember PCS, projected coordinate system, maybe P for plain paper. Okay. Whenever you represent Earth on a plain paper, it is called as a projected coordinate system. Now, in projected coordinate system, it is in meters and meters. Why? Because maybe you choose anything as the reference. Maybe you call it as the equator lines, you call it 0, 0. So, based on it, you can say X and Y. Like 4,000 meters in this direction, and in y 4,000. So based on the xy coordinates, you can define a projected coordinate system. But how do we do that? Why do we need to do it? Now, in geographic coordinate system, I'm talking about geographic coordinate system. We define Earth, we cut Earth in these lines, the latitudes and longitudes. We cut Earth like the pieces of an orange. If you see an orange, it has pieces, right? So we define it like the pieces of orange, and those lines passing through it, we equally spaced lines 30 degree in two directions, one like this and one like this. So we say in geographic coordinate system, we say a location can be defined by two values, that is a latitude and a longitude. Okay. Now, geographic coordinate system is of many types. It is not just a single type. Okay. So the basic part is, okay, cutting out the earth has like orange. But what happens actually is, just remember about geographic coordinate systems. So in geographic coordinate systems, first of all, what is the definition of geoid? Geoid is actually how your earth looks. So if you have mountains at some place, the Himalayas, the earth is high, or maybe you have the oceans, the earth is low there. Okay. So the earth is actually not a sphere. It is the actual shape of earth is called a geoid, how the earth actually looks. Okay. Now you add a reference model to it. Now what reference model means is, here you are adding an ellipsoid. So now this is on you. Either you can add a ellipsoid, or you can add a spheroid, or you can add a oblate. There are many options. Geoid is fixed. However the earth looks, it looks like that only. It cannot be changed, right? Then there is a model of earth that you have created, and you can either put in the reference model as ellipsoid, or a spheroid, or oblate. It can be anything. Now you have cut this reference model based on this classification, that every 30 degrees you have cut it, and every 30 degrees in this direction you have cutted it. So just try to understand. You have a fixed geoid, you add a reference model, and it creates a datum, that is the combination of both. That once you put this on this, the geoid will be cutted like this. Now the particular thing that you need to understand is, if you had put the spheroid model, then the datum produced would have been different from this datum, right? Because maybe in spheroid the earth, the model has a different shape. What it means is, the final datum produced, because in the reference model that you are adding here, for example, this is 30 degree north or 30 degree east, if this point, and it represents a certain location on the geoid. Okay. But if you have a difference reference model, that 30 degree north and 30 degree east will not be at the same place, because in that model the shape of the earth is different. So for different datums inside of geographic coordinate system, the same location is not at the same place. So you need to be very careful about choosing your geographic coordinate system. If I am working in a particular coordinate system, and I submit the data to someone else and he's working in some other coordinate system. When he will convert the data to his coordinate system, it will give an error. The location will change. Okay. Is this clear to everyone? Or there is some doubt? Okay. So basically, just remember this. So just remember this. The geoid is fixed. This is not fixed. You can add ellipsoid, spheroid, or anything. And the final datum produced will be also different. Okay. So every time you are changing the reference model, the location, the datum, how it is produced, it will changed. Now, datum is again in GIS. What is a datum? So just in the back of your mind, you should always know that datum is a reference model created by adding the geoid and a uh, type of the reference model here. Okay. So you need to understand, you need to be able to clearly think in your mind what a datum is. Okay. So datums can be of two types. Even in this, so this was 3D representation of it. Now take the geoid, and when I'm putting the ellipsoid with this, maybe I am placing, because you know the shape of the earth is not completely spherical, right? Now maybe I'm placing the reference model, this reference model, in a way that it is more accurate to a surface, and the other way is to take the center of the geoid and place it on the center of the geoid. Okay. Now there are two ways. Now why we are doing that is, what if you are doing some observations, you have to work on some area, and your observation is area is just here. Maybe you are working on some points here, here, here. So you do not worry, you do not have any observation location in this side. So then in that case, a local datum will give you more accuracy. Okay. But what if you are doing some analysis that you have to take the observation everywhere? Okay. Maybe you have to take the, maybe you are taking observation here, 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 here. So if you are working with a more widespread data all over the earth, you need to have one common geocentric datum rather than local datum. So it would be more beneficiary for you. What if in local datum you took the data here? So it will give you a high error because it is not in line with how the surface of earth, that is the geoid, actually is being represented. Now a local datum, there I will give some examples. One is NAD 27, ED50, WGS 72. And then there is geocentric datum. So NAD 83, ETRS 89, WGS 84. So 99% of the time when you are working in QGIS with a geographic coordinate system, we are always working with WGS 84. So you need to understand that WGS 84 is a geocentric datum. Okay. Because you can use for any location in the world, it is a geocentric datum. If it was a local datum, it would have given us very high error values. Okay. So that is why we are using WGS 84. Now, however, the mathematics is behind WGS 84 is defined. There must have been some reference model that they put in and they created a datum. And based on that datum, we have defined a geographic coordinate system, that is WGS 84. Now, the very important understanding part of it is, as I told you in here, because every geographic coordinate system has a different reference model, so the final datum produced is also different. Now, if I take two different geographic coordinate system, one is NAD 1983 and the other one is NAD 1927. Okay, this is one kind of geographic coordinate system. This is another kind of geographic coordinate system. Now I look at the same image on the Earth at the same place in two different coordinate system, and you can see that the location of this white thing here, just above it was 5640. Let me just show it here, that in this image the below coordinates was 445639, whereas in this image, in this coordinate system, it shifted above it because the reference model used is different. Okay. Similarly, if you see here, the value was near 6621, whereas it is 6626. This value is out somewhere here, 6621. So, in two different geographic coordinate systems, the location of Earth is different. It is not the same. So that is, this point is different. It has a different lat long here in this geographic coordinate system, and it has a different lat long in this geographic coordinate system. So, for example, I am working with some data in my computer. I am working with geographic coordinate system 1927. So when I give it to someone else, I have to tell him use this data in the coordinate system 1927. If you open this in any other coordinate system, it will give you an error. Okay. And at the very back of it, it is based on the reference model. Okay. So 99% of the times we are using WGS 84. That is the geographic coordinate system. Now, after geographic coordinate system, there comes something called as the projected coordinate system. Now, what is a projected coordinate system? So, if you remember, I told you here we defined the Earth as a curved model and defined it based on the cuttings of lat long. Now, when we are trying to represent Earth, the surface of Earth on a piece of paper. Now, if you have this, maybe this is the Earth, right? So, if I have this paper, can you see this shadow part here? So just take this shadow part and project it on this map. Okay. So there are three ways to project the Earth surface on a paper. One is planar, one is cylindrical, one is conical. So this depends on the way you are placing the paper around the Earth. So if I'm placing the paper over it like a plain paper, it is called as planar. Whereas if I'm placing the paper around the Earth, it is called cylindrical. Whereas if I'm placing it conical. So if you see the shadowed part of it, that is what is being projected on the paper. So if I place the paper like this in planar projection, this shadow part is projected here. Okay. What if I place the paper cutting through the Earth's surface? Now, why do we do that is, maybe the area on Earth where I have to take the observation. Okay. Maybe I'm a researcher. I'm just working with this part of the area. So I want more accurate observations. So I have this shadowed area projected on this part of plain paper. My analysis is just restricted to this. This will give me more accurate observation. Whereas I'm not concerned, I'm not concerned with any observation maybe here or here. Okay. So if I have to do more widespread analysis, so maybe my observation area is here, here, here. So then I would select this one. That is, it is touching the earth on one point. Now, this kind of projection is called tangent projection, whereas this is called a tangent case, whereas this is called a secant case. Secant case. Similarly, in cylinder, okay. Similarly, in cylinder, we also called cylindrical projections as Mercator. So what happens is when I wrap around a paper around the earth, so the shadowed part is projected on the map. So what if I am not concerned about the regular spaced analysis? I just want to do analysis in this region or maybe this region. So I would rather than go with the secant case. Okay. So again in cylindrical, we have the tangent case as well as the secant case. Now, why is cylindrical Mercator projections important? So if you're living in Asia, if you're living in India and some Asian countries, this one is really important for you. This projected coordinate system, that is the one we are studying after planar, that is the cylindrical one. This is important for you. Why? Because the cylindrical is typically, sorry, a special case in this cylindrical projection system is what we use 99% of the time, and it is called as the universal transverse Mercator. So if you are working with GIS, you might know that you are using something called as UTM. We use, I told you in geographic coordinate system, 99% of the times we are using WJS84. And when we are working with cylindrical, so that is projected coordinate system, 99% times we are using UTM. Okay. So how do we define UTM actually? So UTM is a special case in which the paper is not folded horizontally, rather it is folded vertically around the earth. Okay. Now, once it is folded around the earth, so the cylinder is moved 6 degree in the clockwise direction. So once it moves 6 degree, this location of this red line, this will change like this, right? It will form like a slice of paper. So what we do is, after every movement, you cut out this part, because observation in this part is better, right? Because the projection system of this is better when it is here in the center. So after every 6 degrees, you cut out the slice and you cut out it into a one complete globe. Okay. So 60 into 6 degrees, that forms the 360 of the earth. Now, you took such one, when it is again rotated, it will form again a slice. So you take all the slices, that are 60 slices, and combine these collectively into this form. So it is called a UTM. Now, what happens is, if you see here, because there is this shadow of this area is very well projected onto the paper. So as you go away from the center, there might be some distortions in projections, but at the center, it is the most accurate. Okay, because it is very simply the center of the paper as well as the center of the earth itself. Now, if you come here, you see that this is the center. Now, this time it is not horizontal, you have taken it vertically. So, this is the vertical center, and this is the most accurately being projected on the paper. So, when you move it by 6 degrees, you create a slice of paper that is very well projected. So that is why we cut 60 outputs, because every time we move, we are getting very accurate papers. Okay. Now, if I directly look into this one, if I take a analysis here, it cannot be projected, right? It will go, it cannot be properly projected. It will either have a high distortion or maybe it cannot even be projected. So I just cut out strips where the earth was very well projected and created into one globe like thing. So that is called as UTM. Now, sometimes people ask, how do I find my UTM zone? So you can just directly write on Google UTM my zone. So there are many websites, for example, this one, Mango Map. Once you click it, it will ask your location. You have to say allow this time, and you saw the strips, right? So it tells you you are located in this strip. So I am located in UTM 43° north. Okay. So if you are anywhere in the world, you have to use that projection coordinate system. Maybe if you are in this area, if you are living in this area, you have to use UTM 40. Okay. So I hope you understand what a UTM is. Okay. Then there is the next thing, that is the conical projection. Now we have the earth like this. We are placing the shadowed part on the paper. We are projecting it. So there is again tangent case and the secant case. And the final geographic coordinate system, because we have a reference model here, we can take any point as origin and we can define x and y axis, and based on that we have it in meters. So always a projected coordinate system is in this value, whereas geographic coordinate system is based on the cuts. So the next part is about resolution. We will discuss what resolution is tomorrow. But until now, if in today's class, if you have any topic that you did not understand or anything that is still confusing you or any doubts you have, we can discuss the doubts. So if you anyone has any doubts, you can just let me know, or you can just write all okay. Okay. Anyone else? Okay, good. So just remember, this is very important for you to. Shall we get the PPT? Yes, I will share it in the WhatsApp group after the class. So just remember, this is a very big problem that people don't understand the coordinate system. Okay. Yes, recorded video of the lecture is available. We are recording the session. And for the recording, you have to ask Nagendra ji. He will share the recording after every class. Okay. So just make sure that you understand coordinate system very well, because whenever you are working with GIS softwares, so the very basic thing that you have to first add to the data is coordinate system. So if you maybe in today's class you are not able to understand what coordinate system is, you can write to me in WhatsApp, maybe directly, not a problem. But you need to get this part clear, okay? If you have any doubts in today's session, maybe watch the recording again and just let me know if you come up with any doubts. So tomorrow we will start with our discussion about what a resolution is and how we define resolution. And then we will talk about the different kind of satellite imageries or different kind of satellite present in Earth orbits. Okay. And just after 1 and 2 classes, we will be starting with the practicals. Okay. So, uh, okay then. I think we are over with today's session, and I hope you had a good learning experience. And if you are very new to GIS, this all maybe have been a lot. If you are very new to GIS, maybe just give it some time, watch the session again, repeat everything, and then if you have any doubts, just come to me. Okay. So I will see all you guys tomorrow. Until then, if you have anything, just write me. Okay. Take care, man. Okay. Bye bye.